Okay, hello everyone. We are all set to start a new chapter. We're going to be doing chapter 3, which for the most part deals with parabolas, but we're going to be working with all kinds of functions, learning how to move functions around, learning how to graph very, very complicated functions. Actually, chapter 3 is going to be a very, very short chapter because we're not going to do the entire chapter. We'll probably do only about 4 sections in this chapter, so we can then move on. But hopefully you will find this to be interesting and not extremely difficult. So we're going to start with, we're talking about parabolas, and I guess my question today is exactly what good is a parabola? So I wanted to show you folks this. And what we have here, and it might be easier for you to see this on the actual PowerPoint rather than on the teaching PowerPoint, but this is a massive solar power plant in the Sahara Desert in Morocco. Okay, and what I find there, you can see it. And I think even on this video, it's pretty clear how huge this solar facility is. When you think about SU's solar plant, I think is on 14 acres, if I'm not mistaken. I myself have solar panels at my house, which pale in comparison to this. This is just absolutely enormous. But the reason why I wanted to show you this, there you see a good picture of the solar panels and what they actually do. They're technically not photovoltaic cells like most of the solar panels that SU has and like I have. What these are mirrored surfaces that bounce the sunlight into one point. And that's the beauty of the parabola. When you have a parabola, by definition, any light that comes in on a mirrored surface on a parabola will bounce and hit at one point. And for this application, it's phenomenal. All that heat from the sunlight in the desert comes and hits that pipe that you can see running down through the middle. This has been positioned exactly at the point that I just mentioned, the focal point. And that really gets hot. It turns fluid into steam, and the steam runs generators, and it powers up dynamos, which make quite a bit of electricity. It says there it gets extremely hot, 393 degrees Celsius or 739 degrees Fahrenheit. That is warm. There's a picture of it from outer space. NASA actually took a picture of that, and you can see how large it is right in the center of the picture there. The other thing I find interesting about solar, that this plant is the way we should be going. There you can see once again the size of all those mirrors. And the interesting thing about solar power is that a German physicist, Gerhard Nys, calculated that the world's desert receive enough energy in just a few hours to provide humanity's power needs for an entire year. Think about that for a second. The deserts receive enough energy in a few hours to provide for humanity's power for an entire year. Okay, very fascinating application of the parabola. And it's well worth studying. All right, so I want to talk a little bit about easy ways to graph parabolas. We know that a quadratic equation, y equals ax squared plus bx plus c, where the a, b, and c are numbers, will give you a parabola. If a is positive, it'll open up. If it's a fraction, it'll be wide. If it's a whole number, it'll be narrow, okay? It is called standard form if you put the parabola in this format, okay? The beauty of this format is we know from chapter 2, when you have a normal shaped parabola here, if you put it in this format, the minus h tells us to move h units to the right, and the k tells us to go up k units. So it's an extremely fast way to graph a parabola if you can get it in this form. But unfortunately, to get it in this form, you've got to be able to complete the square, okay? And that's why I was so much of a pain in the neck on chapter 1 trying to get you to complete the square. So we can either plot points. You can make a table and plot points for this, right? Or if you can get it into this format by completing the square, you don't have to plot any points. You know right away what to do. Completing the square, we work on just the first 2 terms, and there cannot be a number in front of the x squared. You have to factor it out if there was, okay? So this is an easy one. You cut the 14 in half. Now you have to check your work. X minus 7 times x minus 7, x times x is x squared, checks. The outers, when you take x minus 7 times x minus 7, the outers are negative 7x, the inners are negative 7x. That makes negative 14x. That checks. Then negative 7 times negative 7 would be a positive 49. There is no 49 up there. So that means in this right here, there's a 49 in there. You've got to get rid of that 49 so it stays equal. So subtract 49, and we still have the plus 30, makes a negative 19. There you've got it in that format. We know now that if you go to the right 7 this way, and then if you go up 19, heaven's sakes. If you go to the right 7, and then if you go down 19, here's your vertex, and you have a parabola that comes up like this, okay? Now, you should also be able to find the intercepts, where it hits the x and the y-axis. Where it hits the y-axis is extremely easy. Any point on the y-axis has a 0 value for the x. So you simply put 0 in here and 0 in here, and it hits at 30. So we know way up here someplace at 30, this parabola is going to come up and hit there. Now, where does it hit on the x value? On the x-axis. That's a little bit trickier. Where it hits on the x-axis, the y value will be 0, and we would have to solve 0 equals x squared minus 14x plus 30. Can you find factors of 30 that add up to 14? 3 and 10, 2 and 15, 5 and 6, 1 and 30? I don't think so, okay? So we're going to have to do quadratic formula on that to find where it hits the x-axis. Opposite of b is 14 plus or minus the square root of b squared. 14 squared, 196, minus 4 times a times c, all over twice a is 2. So I've got a little bit of calculator work here. 196 minus 120 is 76. So I want the square root of 76, which is 8.72. So I have 14 plus or minus 8.72 all over 2. So if I add those, 14 plus 8.72 and divide it by 2, I get 11.36. One place it hits here, 11.36, and 14 minus, should be able to do that in my head, 8.72 and divide by 2, I get 2.64. And there are the intercepts, okay? All right. Now, let's try this one. 5x squared minus 30x plus 49. Sketch, find the maximum points, finds intercepts. Now, as I mentioned before, you can't have a number in front of the x squared to complete the square. So you have to take the 5 out of the first 2 terms. So I have 5 times x squared minus 6x plus 49. How is my blue marker showing up here? Can everybody read that? I think pretty good. Okay, so now we want to complete the square on the x squared minus 6x. You cut that in half. It would be x minus 3 quantity squared. You need to check your work. X minus 3 times x minus 3. Let's square it out. X times x squared. Checks. Okay? And also, then 5 times the x squared is the 5x squared that we get down there. Checks. Do the outers and the inners. Negative 3x and negative 3x is negative 6x. 5 times negative 6x is negative 30x. That checks. Negative 3 times negative 3 is positive 9. 5 times positive 9 is 45. There is no 45 down there. You need to get rid of the positive 45. It's built inside of that. Get rid of it by subtracting 45, and we still have the plus 49. So I end up with 5 times x minus 3 quantity squared plus 4, okay? And we want to find the maximum and the intercepts. Okay, so what we've got here, we know if you go 3 to the right, because of the minus 3, then if you go up 4, we have the vertex of the parabola there. There's the turning point, okay? We know because of the 5, it's going to be a very narrow parabola, and because it's a positive 5, we know it's going to open up. It's going to be like that, okay? Because it opens up and goes up like this, it's never going to hit the x-axis. So there are no x-intercepts. How about the y-intercept? The y-intercept is always easy because the x value is 0. Put 0 in both of those. It's going to hit way up here, someplace way up here at 49 when it comes up through there. Okay? What else do we need here? We've sketched it. We need the maximum minimum point. The minimum point is right here, 3, 4 is a local minimum. Everyone with me? That's completing the square so you can quickly draw the parabola. If you don't like that method, you can always plot points. Make an XY table and plot points. Okay? I always thought plotting points was kind of a pain in the neck. Oh yes, my nemesis. Why does it do this? Okay, try it again. All right. Next, a ball is thrown up so that its height t seconds later is given. Find the maximum height. Notice we have a negative number in front of the t squared. A negative number in front of the t squared means that it's going to open down. Okay, so we know we will get a maximum height. So let's write this. We've got, I'm going to put it in the right order. I've got negative, so h of t, the height, or just h, is negative 16t squared plus 60t. Okay? Now, I'm going to complete the square. You cannot complete the square with a number in front of the square term. So I have to factor out a negative 16 from both parts. Okay? So if I do that, I get a t squared here, and I get a minus. And if I divide 60 by 16, I get 3.75. So I have 3.75 t. Okay? Now, this is what I need to complete the square on. And this is kind of a pain in the neck problem because of the decimals. So I have negative 16. I have t minus, and I cut that in half. So divided by 2 is 1.875. Quantity squared. I've completed the square. Now you need to check your work. You'd write this down twice. T times t is t squared times negative 16 is that. Perfect. When you do your outers and your inners, because we just cut it in half, we know that negative 1.875t and negative 1.875t will add up to negative 3.75t. We know that. So let's square the and times. Then the negative 16 gives me the positive 60. Checks. Now we need to square this. So 1.875 squared gives me 3.52 when you square that, okay? Then times a negative 16 gives me a negative 56.25. There is no negative 56.25 up there. When you square this and took it times a negative, that's what you get. We don't want a negative 56.25, so we have to add a 56.25 to get rid of it. And now we've got it. We've got it perfectly. We know that if you go to the right, 1.875 right here, go to the right, and then if you go up 56.25, you come to that parabola, okay? And what is the parabola again? It's very narrow because of the 16, and it's negative, so it opens down, okay? What's the maximum height? 56.25. A bit of a pain in the neck because of the decimals and fractions, okay? All right, next one. This is just a basic problem, sketching a parabola. X squared plus 4x. This one should be an easy one because there's nothing in front of the x squared, and this is really easy to cut in half. So cut it in half, x plus 2, we've completed the square. Check your work. Write it down twice, x times x, x squared, checks. Inners and outers, 2x and 2x, 4x, checks. 2 times 2 is 4. There is no 4 up there. I need to get rid of the 4. Okay? All right, so here we go. We want to sketch it. I go to the left 2 this time because of the plus 2. I go down 4, down to here. It is a positive x squared. It's going to open up. And so before I even sketch it, let's do the intercepts. Intercepts. So here we have, to find where it hits the y-axis, you simply put x equal to 0, and that turns into 0, okay? To find the x-intercepts, you set y equal to 0. And if this is equal to 0, you can take out an x, and I get each one is set equal to 0. I'm going to get 0 and negative 4. I already knew 0, and there's negative 4. So now I know my parabola comes up like this and like this. Okay, I'm to find a max or a min. The minimum point is negative 2, negative 4 for a minimum. And I think I've done everything. Okay? All right, next one. Same thing, doing exactly the same thing. So I have h of x, negative 2x squared plus 4x minus 5. You should know before we even get started, a number is going to make it narrow, negative sign, open down. So even before we even do any bit of work, you know instantly what it's going to look like. It's going to be a little tricky because there's a number in front of the x squared. So let's pull that out of the first 2 terms. So I have negative 2, and then I would have a minus 2x. Do you agree? Check your work. Negative 2x squared, positive 4x. Checks. Minus 5. Now, to complete the square, you cut that guy in half, and you've completed the square. Check your work. Let's write this down twice and FOIL it. X times x is x squared times negative 2 is negative 2x squared. Checks. Outers, negative 1x. Inners, negative 1x makes negative 2x. Times negative 2 is a positive 4x. Checks. Negative 1 times negative 1 is 1. Times negative 2 is negative 2. There is no negative 2 here. So I must get rid of the negative 2 by adding a positive 2 minus 5. And I have negative 2, x minus 1 minus 3. Get a look at what this parabola looks like. You go to the right, 1. You go down, 3. There we are. And remember, this negative sign means that it opens down and it's narrow, okay? Notice because it opens down, it is not going to hit the x-axis, right? So we don't have to worry about x-intercept. But the y-intercept is easy. You go back and just set these equal to 0. It's going to hit at -5. So right here, it's going to come down. My graph is not perfect. It's going to come down and hit at -5. Okay? That's the y-intercept. All right. This is kind of a fun problem. This problem was born when I was on my way to SU. What in the world? Oh, my word. Yes. Okay. So I was on my way to SU one day, and I heard how the Pennsylvania Turnpike was going to be increasing their tolls. They were talking about it on the news. And they said that they understand that every time you increase the tolls by X amount of dollars, you lose some cars because cars will try to find a different road to go on to avoid paying the toll. And I thought, yes, what a great problem. So I come up with a great problem here. Suppose you have a $5 toll, and every day 3,000 cars go by on the road. Statistical studies show that for each dollar you increase the toll, you're going to lose 300 cars. You follow what I'm saying? So say right now you have 3,000. Did I say 300? Yeah, 3,000 cars go by daily. So 5 times 3,000, you make $15,000 right now on every day. Okay? If you put it up to $6, you're going to lose 300 cars. You're only going to have 2,700 cars go at $6. Should be able to do that in my head. 6 times 2,700 is 16,200. So even though you lost 300 cars, at 16,200, you're better than the 15,000 that you've made now. You see? So even though you lose some cars, you're better off. Now, will this continue to go? Eventually, you're going to lose so many cars that you're going to make less money. What we want to find is, what should the toll be to make the most money? Oh, is this a great math problem or what? All right, so let's talk about it. Right now, the money that we earn, the money that is earned on this toll road is $5, and we're going to take it times 3,000 cars. Yes? Okay? Now the question is, how much money should we raise it? How many extra dollars should we add on to the 5? I don't know. So I'm going to say it's 5 plus X. Okay? X amount of dollars. All right? Like we said, if it's 1, we're going to lose 300. If it's 2, we're going to lose 600. So in other words, then how many cars do we have? With X dollars increase, you're going to lose 300 cars for each dollar. Right? So just follow with me here. If it's $1, like I said, that's $6. You're going to lose 300 times 1. It's 2,700 cars. If it's $2, take it up to 7. You're going to lose 600 cars, and you're down to 2,400 cars. You with me? All right. So now what we want to do is we want to find the maximum toll, the best toll to make the most money. We want to get a maximum. Look at this. X times negative 300x is negative 300x squared. That's a negative squared term. It's an upside down parabola with a negative 300 in front, super narrow, okay? But it's a parabola. All right, so let's multiply this out. So I'm going to FOIL this thing out. 5 times 3,000 is 15,000. Okay, I'm going to put it at the end. Your outers and inners are 1,500x and 3,000 or 3,000. 3,000 minus 1,500 should be a positive 1,500x. I think if my brain is working. And then x times that is a negative 300x squared. So there's my function. Okay? All right. So Let's now work at completing the square. It's going to be a little tough because there's a number there. So I'm going to have to pull that number out of the first term, factor out negative 300, and I'm going to have x squared minus 5x. Yes? Okay? Plus 15,000. All right? Completing the square on this, you have to cut that in half. And 2½ or 5 halves when you cut it in half. I have now completed the square. Check your work. X times x, when you square it, x times x is x squared, times negative 300 is negative 300x squared. Negative 2½ on the outers, negative 2½ on the inners is a negative 5x, times a negative 300 is a positive 1500x. Checks. Now, negative 2½ times negative 2½ is a positive 6 1/4, I think. Yeah. So 2.5 times 2.5, yeah, it's 6 1/4 times a negative 300 is a negative 1875. Okay? Negative 1875. There is no negative 1875 here. There's a negative 1875 in that, and we don't want it. You've got to get rid of it. So we add a positive 1875 to the 15,000, and I get 16,875. Yeah? Okay? And boom, you've got it. This parabola is to the right 2.5, and you go up 16,875. But what was x to start with? X to start with was the additional dollars that we should add on. And what should we add on? $2.50. 2.5. We should add on to the 5. And we will earn 16,875. So the optimal toll, the best toll you could charge, adding $2.50 to the 5 is $7.50. Is that a great question or what? Okay? Oh, yes. Mathematics is so much fun. Okay, so there's going to be a lot of completing the square, a lot of parabolas in this assignment. Okay? Good luck.